All right. I am going to be going over worksheet 2D. I'm going to go over worksheet 2D. So some of it can be done without the calculator. Some of it we're going to walk through and do with the calculator. So if you don't have the graphing calculator, one, yet you're required to have it. But I do have 10 of them. 8th period was kind of funny because as soon as they were gone, it's like, oh, sorry, it's just like real life. So I'm hoping that 5 of you already grabbed one of my calculators. Is that true?
I did.
Raise your hand if you grabbed one of my calculators. 1, 2, 3, 4. Oh, good. There's 5 left. So if you need one, grab one. Now there's 4 left. Now there's going to be 3 left. Come on.
Mr. Sir,
Yes,
how about if I make this shot? If I make this shot, can we do no homework?
You got it, yeah.
Oh.
Triple the homework now.
I was clue.
All right. So, problem number 1 says the scatter plot below represents data collected from, this is Math, as you graded our latest chapter test. And so they've already got a line of best fit, or they already have the data plotted, so we don't have to go and plug it into the calculator. Draw a fitted line. So this one, all you would have had to have done is take a straight edge of some sort, aka a ruler or something else that's straight, and connect as many dots as you can without doing this. Don't do it jagged, straight line. Find the equation of line and the equation in slope-intercept form. Okay, all right. So, let's go here. Turn that on. So, everyone's okay with, are you okay with finding a line of best fit? Is anyone stuck on that concept? And I'm not talking about the one on the calculator. I'm talking about old school using a ruler. Yes, literally a ruler. Down. Oh. Look that one. There's that one. All right. So the first one, we don't need to use the graphing calculator at all. I'm just going to connect here. Switch back and forth. All right, it's a negative slope. Agreed? And as far as our line goes, it looks like we can say something as, let me get down to the bottom. So I'm just going to draw a rough representation of what this looks like. Right? And this is minutes of grading. And this is number of tests. That's a silly representation. All right, line of best fit. Literally just something the best you can with that. And then find the equation. So if we find the equation, we want to find 2 dots that we feel good about. And I would find, honestly, I'd try and find 2 that looks like might have 22 and 60. And I'm just picking something from somewhere on the outside, so 22 and 60, and then 95, comma 30. Did the stapler make it?
Wait, can I get the stapler again?
No.
Are you kidding me?
Just throw it.
Yeah.
Okay, here's your personal stapler.
Don't give
there.
it to him.
Get here. All right. On this one, we don't need, all we have to do is find the slope. So slope equation, if I go 30 minus 60, I get negative 30. Agree?
Okay.
And then, is that okay? 30 minus 60. And then 95 minus 22 is?
40. No.
speaking? No?
Wait, anything she ever says just doesn't make any sense. It's 73.
Okay. All right. So our slope is negative 30 over 73. If you pick two separate points, your slope's going to be a little bit off. Agree? It doesn't mean you're wrong. It's just you're off. I mean, any of the two of the points you pick, if you pick correctly, you should have a negative slope. For the most part, this means number of tests, minutes grading. So 30 tests are graded every 73 minutes, or if you can reduce it, 3 tests are graded every 7 minutes. That would be how you could read that. So that's what it means in the context of the problem. Identify the y-intercept and explain what it represents. So the y-intercept's up here. Looks like it would be close to 0, 80. Basically means she has 80 tests to grade. She hasn't done a thing yet. Got it? That's usually how us teachers feel after we give a test. Walk into the office, especially if it's a Friday, going, sweet, I won't worry about this till Monday. Come in on Monday going, oh, dang it.
You can always put it off for another 3 weeks.
I know. But we're math teachers. We're pretty quick. There's other teachers where it's like, it'll be 15 weeks into the semester. And it's like you got 1 grade in the grade book because we can see like back it up. And it's like, what the heck is this teacher doing? It's like you're in health or whatever with Goldsberry. I could rip on him. Yes, I can rip on him. Bless you. I'm just kidding. Go ahead. There's one more. Come on. Stop looking at me. All right. That's how you do this first problem. There was no graphing calculator. Agree?
What's the answer?
What is the y-intercept in the concept? 80 tests left to grade. The slope in the context of the problem is 30 tests are graded in 73 minutes. Or if you kind of reduce it where you don't worry about that, 3 tests every 7 minutes are graded. That's all you need to write. So, and then find the equation line. We didn't find that yet. All right. So y minus y1 is negative 30 over 73, x minus x1. So there's your equation and point slope. If it just asks for the equation of the line, I would stop there. Why? If it just asks for the equation of the line, why would I stop right there? Yeah, you have the equation. Now, some people are like, dude, I want to solve for y. But the thing is, I'll grade your test or quiz or whatever it is. If you get to here and you leave it, you're done. Now, if you're like strange in the head and you want to distribute this and then add 60 and then you make an error, I take a point off then. Does it?
Yeah.
Find the equation of the line. Oh, it must be in slope-intercept form. Thank you. I'm like most guys, only read the first line, first few words. No instructions. All right.
And the book said something else from the slope.
What?
If we're like, the book said something, like the answers like in the book said something else from the slope. So if we're like close.
So yeah, you're totally going to get it. What I would look for on this is roughly 3/7 for a slope.
Okay.
Roughly. Okay? Now, mine is that. Why would I say 3/7 versus 30 over 73? Yeah, they're close. So I'm going to be off because I didn't pick the exact points that the book did. X plus 60 over 73. Oh my gosh. Come on, catch up with me. I'm not the fastest person on earth. I can't think that quickly. So the computer should be able to stay with my writing. All right. That's basically what it is. 60 and 60/73. If I do it right, I don't know. Is this off from what the book has? Yeah. Did the book choose two points that I didn't pick? Yeah. Did you pick different points than me in the book? Yes. Is that okay? It is. I'm trying to make it okay. So, just real quick, if I had, I said what? Let's say that's my data. Is that all right? And then you draw in this line of best fit that you want to look like this. Of course, it didn't work the way I wanted to. Just can't have nice things on these days. So here's my line of best fit. If someone were to pick this point and this point, you almost have a vertical line. So that's not really the best way to do this. So in science, I'm pretty sure they would have asked you to do it this way. Find 2 points that are pretty close to your line that are far apart. If you pick the line of best fit, you make the line of best fit using these two, that's what the line of best fit is. So more spread out, closer to the line as possible. If someone were to pick this point and say this point, so this was 1 and this was 1, they're going to have a slightly different answer than the person that picked this one and this one. Is that okay? Yes. But if it's the student that's using these, that's where you're making the error. You're picking them too close together. You know, let them be spread out. Find them as close as possible to the line itself. Okay? And that's what we're doing with that. Okay, so then problem number 2, the data in the table represents the cost of setting up a screen print and making a certain number of t-shirts. All right, I'm going to do this one on the calculator. Why is that? Because I can. Okay? Computer. All right. I'm going to walk through this as slow as possible for all students. I will always show you this way for a reason. Okay? Some of you have borrowed calculators, so some students like to plug all kinds of stuff into calculators that has nothing to do with it. A lot of times I'll look into y equals and it's like tangent, sine, log, ln, z. And then anytime you graph the calculator, it goes, I don't know what this means. Okay, so, but that's just how students are. So this is how I'm going to do it. Ready? What this will do now, if this is your own calculator and you have all these fancy games on your calculator, put the games on your phone. Get them off your calculator. 2, what I would do is this. I'm going to go second. Am I on? How far off am I? All right. I want this off. All right, I see what I have to do.
Hey. What?
Why did you do that?
Because it's pay.
Oh, yeah. Mine was so bad.
I love that joke.
You know what it is for my like
All right. Here we go. This should work now. I'm at the pointer. Good. Here we go. Shh. Ready? Set. Here we go. I'm going to hit second.
Okay.
Not trash. Second. Memory. Second plus key. Stop.
Plus?
Whoa.
Second and the plus key.
I'm going to hit 4
Oh
or
my
3.
God.
Then hit second plus again.
No, I was joking.
Okay. I am. Does everyone get to this?
Yeah.
Anyone like, dude, I got something weird?
No.
All right. I'm going to now hit this. I'm going to hit reset. Number 7. I'm going to reset at number 1, and I want to reset it.
This is a trap. This is how the games get
Wait,
deleted off your
what?
calculator.
Oh, what?
So I press 1
All right,
on
ready?
phone,
I'll go back through it again. Hush. Here we go. Ready? Hang on. Second plus. Go down to number 7. Hit 7. Go to number 1 and reset it. Hit number 2. And what that does is it wipes out anything that was in Y1, Y2, Y3, Y4. It wipes out anything that was in stat in the edit in the columns. It gets rid of the stuff that's hidden. Now, what does that do?
Takes away your key.
Yeah, you have
What?
cooler stuff on your. You don't have games on your calculator.
Yeah, you can
I
do
do.
it on your
No, you
calculator.
don't.
Yeah.
Don't worry.
Yeah, that stuff's archived. It'll stay there.
There's Mario.
I do have.
I mean, that's.
I do have probabilities.
It's not going to knock it off. That's stuck in there. All right. Shh. Ready? So now, I'm going to go second. Y equals. I need to turn my plot back on because now I reset it, turned it off. So 1. So you want that blinking on, you hit enter. It's now on. Then what this does is it says, hey, this is on. We want a scatter plot. We're going to use list 1, list 2. Are you going to use a square plus, a big dot, or a small dot? And the color. All of this doesn't really matter. You know, some people are like, I want a plus and I want this aqua green that you only see in 4 shades of light. You know? And then during it doesn't show up. Yeah, you want to know why it doesn't show up? Just take the default ones, you'll be okay. All right, so now our stat plot is ready for us to enter information. Ready? Stat. Stat button up there. You can't find it, it's red on my screen.
Wait, how did you What did you do?
Stat.
Stat.
And this is all recorded, so you can you can play on it. All right, we're gonna edit. If you went through this whole thing and deleted, you shouldn't have anything in L1, L2, L3, do you?
Wait, what did you do with your stat? I got lost.
Wait, I can't hear you.
Never
Stat
mind.
what?
Say it one more time. Stat edit.
It's that.
Got it.
Everyone there?
Yes.
All right. I'm gonna enter. Enough of the whistling, please. All right. Shh. I'm using my worksheet. I'm going to plug the following in. The number of t-shirts, I'm plugging into L1. So I'm going to go 3, enter, 5, enter, 6, enter, 8, 9, 11, 12, and 14. Double check your list. 3, 5, 6, 8, 9, 11, 12. If you made an error, arrow back up to it. Everyone with me?
Yeah.
All right, go into list 2. So now we're over here. Now you got to make sure your list 1 values line up with list 2. So don't have like 3 go with 120. Okay, 3 goes with 44. Once you have it there, so 3 comma 44, that's your first piece of data. And this is number, and then I got 5 comma 60. 668.
You did it wrong.
Oh, I did? Oh. So watch how easy it is to fix. Arrow back up to it. 6, 0, enter. Done. 68, 82. Enter. 87. Enter. 100. Enter. 107. Enter. 120. Enter. All right. Biggest error that takes place on these calculators is you enter data incorrectly, or you didn't have enough data matching up with list 1 and list 2. Like you have 15 pieces of information in list 1 and 14 pieces of information in list 2. So it doesn't read that. Okay? Now, we turned our stat plot on. Agree? That means it's ready to graph. But hang on, before you're like, oh, sweet, let's hit graph, and then panic when there's nothing there. 3 comma 44 won't show up on your graph because right now your graph is set to -10 to +10 in both the x and y direction. Make sense? So then we have to tell the calculator, hey, calculator. And it's not in the voice recognition mode. Sorry about that. So I'm going to go zoom, that very top button. And the zoom stat, which is number 9, is going to allow us to, boom, look like that. That's my data. It adjusted the window for you to make your data fit. Now, here's the nice thing. Usually when you're doing these types of problems, you'll kind of know if one of your points might have been goofed up because you might have a point way down here. You have all this and then one down here or one way up here. If you made an error, don't just pause. If you made an error, you can go back to Stat, Edit, and take a look at your data and make sure your data was right. Okay? But your graph is now set up. Now here's the bad thing. Your graph is set up to this window until you tell it later to do something different. So if you're sitting in your chemistry class and you're trying to use this going, dude, my graph's all jacked up. I know, because we adjusted it to the window for this problem. And I'll show you how to take it back. All right. Draw a fitted line to model the data. What type of correlation do you see? All right. Now, put your calculators down on your desk. I just want you to see this real quick. First off, does it look like the slope will be positive or negative? Positive. Would you think there's a positive correlation to this?
Yeah.
Does it look like a line of best fit would fit really nicely on this? Meaning,
Yes.
okay, hang on. I wanted to show you something. You don't have to do this. Don't try and find it. All right. So I'm going to second catalog, and then I'm going to go down to diagnostics, which is letter D, and I'm trying to have my diagnostics on. And I'm going to explain to you what this means. Don't worry, you don't need to have this yet. But my diagnostics are on now. And you're like, great, what the heck does that mean? Don't worry about it. I don't need you to worry about this yet. But I know my diagnostics are on. So now we can go back to our calculator. Don't worry if your diagnostics aren't on. I'm going to have it up here. We're going to take a look. Ready?
Yes.
I want to find the line of best fit. Stat. With me?
Yeah. Yes.
I am going to calculate my line of best fit, so you would think it should go under calc. All right. I am going to look at linear regression. 4 and 8 are both linear regression. We want number 4. We're not French. We don't use the 8th one. So you hit number 4. All screens are going to be a little bit different, but they're going to do the same thing. Remember we use list 1, list 2? Does that agree with list 1, list 2?
Yes.
Okay. Frequency list, I don't care. Store, regression equation, I'm not worried about that. But I can go now to calculate, hit enter, and it tells me this. Now, I'm going to look a little different than you. You'll have the A and the B. You probably don't have R and R squared. Okay? But I'm going to explain what R and R squared mean. But this means my equation is y equals 6.785x, that's your slope, plus b, which is 25.82. So your calculator does the work for you. It finds the line of best fit. Now, here's the great thing, and we will get to this eventually. The R value and the R squared value mean two different things. Can I go off on a tangent and tell you what they mean?
Yeah.
Okay. Your R and your R squared value mean this. You have your line of best fit. And you draw this line in. And it tells you that you have y is equal to, I don't know, 3/5 x plus 0. Or let's make it negative 0.5. So, because it comes down just a smidgen rate. Okay? So that's what they say the line of best fit is. How your calculator determines R and R squared. Okay? You want to know what the big difference between the two are?
Yes.
You know what R squared equals? R times R.
Oh.
You want to know how to find what R is equal to? You take the square root of R squared. Okay? Now you're like, dude, okay, that's the real simple stuff. Now, what all this information really is doing is this. Here's your R value. It's finding the average distance to these points. Okay? It's just finding a distance. And then what it does is it adds it all up and finds the average. And the closer that average is to 1, the better. The closer it is to -1, the better. If it's -1, that means it's a negative slope. Now, I won't have a negative R squared value. Why is that? Well, because if I go R times R, I get R squared. So a negative times a negative is positive. Now, here's how your calculator finds R squared. It literally makes a square, these little tiny squares. You're not seeing it, but what it does is it adds up the area of each of those squares and divides by the amount of data. And so the closer R squared is to 1, and the closer that R is to either -1 or +1, the better your correlation. Okay? If r is a negative value, it means you have a negative slope. If r is a positive value, you have a positive slope. You can't tell what your slope is by looking at r squared because that will always be positive. That's what that means on my calculator. Okay? So, if I look at r squared, that's a two-dimensional analysis. If you were to take a test in here and I gave it back to you and you had a 99.7%, you're pretty stoked about that? You're like, dude, I did well. Every now and then you get the one person who's like, I want to know what 0.3% I missed. Okay. Come see me then if that's that important to you. But most of you in the class, if I gave you back a test, you'd have people go, yes, 99.7! Right?
I mean, you would be a little It's like 1.3.
That's a youth thing.
Looks like you're coming to see me after every test going,
Yeah.
show me where we
No, because I'll just be in
That's okay. All right. So everyone's good? So we're happy with a 99.7 or 0.997. So the calculator has done its job. Now, find the equation of line of best fit. So we want to take our line of best fit, which is y equals 6.7857 x plus 25.82142.857. And you can type that all into your y equals if you wanted to. But that's goofy. This is stored. Ready? Does everyone have this at least? Minus the r squared and r?
Yes.
Ready? Y equals. Oops, I gotta change my thing. Silly stuff. I gotta trash that. Good. Y equals. Still with me?
Yes.
We are going to put that information in. Now, so those of you that wrote it down, you can sit there and try and plug in those 9-digit decimals. But the rest of us, we're going to do this way. Y equals, everyone there?
Yeah.
VARS, V-A-R-S. It's red up on the screen. We're going to go down to statistics number 5. We want to find our equation. And we have the regression equation, number 1. Now your calculator has stored that big old decimal in there for you.
Wait, is it one?
Oh.
VARS, right here. Statistics, equation, and then number 1. So once I have that in there, if I hit graph, giddy up. Line of best fit's in there. Better than anything you could have drawn on your paper. Why is that? Because you have a spiral notebook, it's sitting on top of your phone. You're kind of like, think you have a straight edge, but you sneeze while you're drawing it, so it's moving around. Now your calculator did a nice job.
It's not straight line. That's awesome.
It's kind of straight on there. All right. So identify the slope and what it represents in the context of the problem. Well, we just said that the slope was 6.7. All right? Our slope is 6.7, right?
6.8.
Okay, 6.8. 6.8 is our slope. So what does that mean in the context of the problem?
The price goes up by $6.80.
$6.80 for every one shirt I buy.
Yes.
Okay? So the cost goes up $6.80 for every one more shirt I buy. So it's 6.8 over 1. You don't have to convert 6.8 to a fraction. There's no need to. Just realize what your slope means. 6.8 over 1. Okay, what does that mean? $6.80 more for each additional shirt that I order. Okay? Identify and explain with slope. We got that. Identify the y-intercept and what it means. The y-intercepts are b value, right? So if you go back to y equals, and you go over on our thing, looks like we got 25.882. Keeps going. So 25.82 is, you're spending $25.82 just for them to set up the shop. You haven't even ordered a shirt yet. Okay? So you think about it. If you order a shirt, most of you have some sort of shirt that has some sort of logos on it. So that store had to go to someplace. They had to set up some stuff for you. So you're paying $25.82 before they even start printing shirts. Where you start coming down on that price is you start printing a lot more shirts and selling them, you start absorbing that 25.82. But if you're like, hey, I want one shirt, well, we already said that it's $6.80 a shirt, right? Plus that $25.82. So that first shirt cost you the most because you had that setup fee.
How do you find the x-intercept?
Did it ask for that?
No, but it asked for it on the last problem.
Okay. All right, so let's do this. Graph. So we're at our graph, right? Can I see my x-intercept?
No.
So what we'd have to do is this. We'd have to zoom out. So zoom 3 and hit enter. Can I see my x-intercept now? So zoom out, enter. Okay? I want to find the x-intercept, which is this. Agreed?
Yes.
What's that? Well, that's 8.5 comma 82. So what I can do is this. I can go second calculate, so second trace. I want to find a 0 because a 0 is where it crosses the x-axis. I can then move my, I have to move my cursor below it because it's looking for the left bound. Am I to the left of where that crossed the x-axis? Yeah, so you hit enter. And then I'm going to move to the right of where it hits the x-axis. Am I to the right of where it hits the x-axis? Hit enter, and then it says, hey, do you want to guess? No, give me the answer. So you hit enter one more time. So at negative 3.80 is our x-intercept. The calculator is an unbelievable tool for you. Do you master it just by trying a problem or two here or there? No, you really don't. Okay, it's a tougher thing. So let's hold off on number 3, and I'm going to go to my notes because I have just enough time. So do me a favor. Let me have packet 2C. That would have been due on Friday, and I told you to take another day, right? So pass that forward. Don't pass the other one forward yet. We'll work that one out tomorrow. Huh? Not D. Hang on to D because we can work that last problem. Cool?
You want to go for it.
We're good. We're really good. All right. So real quick, Friday this week, I will not be in class. I will be at the med school with like 25 of our students, including Kate. Okay, but what I will do, does everybody know how to find Schoology on your phone? Okay?
Sure.
Once you get on Schoology, do you know how to find my page on your phone?
Yes.
Once you find my page on your phone, you can look to where my notes are and my videos. So what I'm going to have you do on Friday is I will have basically a 40-minute video for you to watch with notes to fill out.
Friday. What's Friday?
Cadaver Lab.
Oh, so you're not going to be here? He's not going to be here.
I won't be here because I'm donating my body to science and I'm allowing our students to cut into me. It's cool. Just kidding. Just kidding.
But it's a real dead person.
It's a real dead person. They really died.
Yeah, they really died.
They really died. We really filled them full of radiator fluid.
This guy, I took pictures of all the gross stuff.
Am I
So
gonna vomit?
Did you see? We had a girl pass out again.
Yeah, I saw that.
She passed out again?
No, a different one.
Wait, this guy was like setting like
She was in the
fireworks,
restroom
and
and
he
a
comes
student
in
got a
without
text.
a hand.
My friend said she's
And then this other,
So I
there's
went
a
and got her,
picture of it.
sat behind the wall. That's when I said,
And then there's another picture of a guy holding
make
his
sure
hand
she's okay.
He got his hand stuck in the
Okay,
and it's like a totally cut
Yes.
shape, but like you can see the different layers of stuff.
Some of that stuff we saw today, it was good.
It was so cool. And then
The guy who blew his hand off with the firework. They show the X-ray
If you
first.
blow
Oh,
your-
what's a missing? His hand. They show the hand and it's nothing.
if you blow your hand off during fireworks, you deserve not to have a hand. That's so dumb.
I understand.
And then there was this other guy who was riding a motorcycle, and he got thrown off the motorcycle, and he got stuck in a tree,
So
and so then he had a tree branch in his chest right here.
Yeah.
And so he drove his motorcycle home, got in his car, drove to the fire station, and the fire station took him to the hospital. And it, like the shirt was inside his arm too because he was wearing a shirt and the stick got stuck into his arm, and there was like a shirt. So they had to take it out. It was so cool. It was really cool. No. It was yeah. It was so good.
Like, hey y'all, I got a tree branch in my body, no biggie, but when you get to it, can you help me? Wait, is that all you guys do? You just look at like really
No.
crazy pictures?
Only two. It's only
Two so far.
It's only been two lectures that have been really bad.
And
But
the two
they're
bad
all-
ones, we had one person pass out each time.
Yeah.
There's a slice on top
Are you guys gonna get
He was in sports medicine. So he did a lot of, he showed us videos of how when you like
All right. Everyone have notes? All right.
He did a lot of because sports.
Are you guys gonna do like conventions and stuff? That'd be real neat.
Oh, we gotta get
There we go. All right. First thing I want us to do is I want you to copy down the data that I have up here. So I am going to slide number, I think we're on 5. Slide 5. Write that down. And you can write it down as ordered pairs if you wanted to. Just, yeah, write it in slide 5. So write that in. Distance, miles, and there. I don't know why this didn't print. So just copy that down. Yeah, I don't know why it doesn't copy it. I think this.
Maybe it's afraid of being expelled because like copying someone's work is like
Could be.
cheating.
Does anyone need more time writing that grid down?
Yeah.
15 more seconds.
Oh, no. Can you not write
Olivia, what number are you on? Right here.
I'm writing the words.
Are you kidding me?
I don't need to do that. Just the words of the table or both.
I would say that know the table, and I'd go miles, hours. That's it.
Did you really just erase everything? Yeah.
All right. This one says your big brother is coming home from college to attend your big event. The table below indicates the distance he is from home each hour he left from his something. I can't
So
see.
you going to read it?
Which variable would be x? Which variable? And then find the equation using your calculator. How strong is the correlation? All right. Does everyone have this written down?
Yes. Yes.
Ready? All right. I'm going to walk through this the exact same way I've done it before. Ready?
Okay.
See if I can go through it a little bit quicker this time. All right. I know. Second, memory. Reset. All RAM. And reset.
We have to do that.
It's always a good thing to do, especially if you're using the calculators from my class. All right? Again, it just makes everything. The nice thing is if you do that and you walk into your science class, your calculator will work for you now because your window's not adjusted. So you go second memory. Second memory, reset number 7,
Don't forget to turn your plot on.
and then reset.
And then turn your plot back on.
All right, so then I'm going to go second, y equals. Second y equals. Plot 1 I want on. Hit enter, so it's blinking out the on spot. Quit out of that. Stat. Did I go too quick?
No.
All right. So distance versus time. Miles per hour. Miles hour. So distance is Distance is your y component times your x. So under here, I'm going to edit. In list 1 is going to be my x, so I'm going to plug in 2, enter, 5, enter, 6.5, enter, 8, enter, 10, enter. Is that okay?
Yeah.
Do the same thing to y2. Plug in your distance. Make sure you're matching up. 490. 315. 170. 120. And 20. Enter. Once you're there, what was next? Zoom stat. Good. So zoom number 9. There's our data. Hey, is that positive or negative slope?
Negative.
So is it positive or negative correlation? Negative. Yay. I still have time. Don't start packing up yet. So now I'm going to go here. Ready? Second. Stat. Calculate. Linear regression. Enter. Calculate. There's my line of best fit. So I have a slope of negative 59. So about negative 60 plus 600. So the y-intercept represents your brother 600 miles away. Every hour that your brother drives, 60 miles is taken away. So if you wanted to find this and plot this, you go y equals. Okay? Where is it? Where do I go? Where do I go? Bars. Statistics. Equation. Graph. That's it. That's how you do this. All right. So, I would like to make sure that you're getting your homework done. So, try the best you can to have let's try and have 2D done and then also have 2E. Try and have both of those for tomorrow. If you borrowed a calculator, please put it back.
2 E's homework too.